So let's compute two examples of complex integral. This is following the last video. So let's first compute integral 1 over z as a complex value function on the complex plane with gamma the parameterized curve of the circle with radius r. So this is z t equals r times exponential I times, let's say, 2 pi of t, and so defined 0 to 1. When t goes from 0 to 1, this goes from 0 to 2 pi. And so this gives one circle. And let's say this radius r is not 0. Actually, we will say that no matter what it is r, even it's negative, as long as it's not 0, this would give you the same result. Secondly, let's compute another example. Let's compute this fc equals constant function along any smooth curve parameterized by some zt with t taking from 0 to 1. Actually, we will show that this is independent of the smooth curve, only depends on the endpoints. So, solution. So by our definition of integral of complex value function along a smooth curve, parameterized curve, this is so t from 0 to 1 over r times exponential I to pi t, and there we put this derivative or velocity dt, right? So this is, let's simplify it, 0 to 1 over r exponential minus I to pi t times the derivative of zt. So the derivative is derivative over t, so exponential pi t doesn't change, and then 2 pi I r times exponential I to pi t, then 2 pi I, and then dt. This is integral 0 to 1, r and r cancels. This cancel, finally what you have is only this. This is constant. And the integral 1, which gives you 1, 2 pi I. And you say, remark, for any r doesn't equal 0, this gives the same result. Second example, integration of 1z same, that is, we don't have enough information to compute it, but what can we do? Just use the definition. This is again velocity of z dt, and now t from 0 to 1. But then by the fundamental theorem of calculus, the complex version, because it's a complex valued function, continuous function with one real variable, so this is just z1 minus z0. So remark, this is independent of your choice. Curve, but only the endpoints. So this is very different from integral real functions. This is not the length of the curve gamma. So this integral along the curve of constant function is not the length of the curve gamma.